Hey everyone, welcome back for another deep dive. One of the most fundamental concepts in economics is supply and demand, right? It's like Econ 101. But how well does this classic model actually hold up in the real world, especially when the assumptions it's built on? Well, they don't always quite match up with how things actually work.
Yeah, that's a great point, and that's what we're going to explore today. We're diving into some really interesting material. We've got excerpts from an academic chapter focused on market experiments and a book called Experimental Economics, Game Theory and Market Behavior.
And what's so cool about these sources is that they go beyond just the theory. They look at actual economic experiments, where researchers try to create controlled environments to see how people actually behave in markets.
Exactly. These experiments are designed to test those elegant theories we all learn about and see if they really align with, well, sometimes the not so elegant ways humans actually make decisions when it comes to buying and selling.
So our mission today is to get past those idealized models and really dig into the fascinating and often messy reality of how markets actually work. We'll be looking at everything from early experiments in the 1940s, like imagine trying to recreate a market in a lab, all the way to modern auction theory and even the psychology that influences how we bid. So buckle up, folks.
Okay, sounds like a plan. So to start, let's quickly revisit that bedrock of economics, the standard supply and demand model. The one that gives us this framework for understanding how prices and quantities get determined in a market. It relies on a few key assumptions, right?
Yeah.
Like that all the buyers and sellers out there are perfectly rational, always trying to get the most bang for their buck, and that there are tons of them, enough that no single person can really sway the market.
Right, right. Except, as anyone who's ever, I don't know, impulse bought something on sale knows, we're not always perfectly rational. We're emotional beings. Our decisions are influenced by all sorts of things. And let's face it, lots of markets, especially for specialized goods or services, don't have a huge number of players.
Absolutely. So that begs the question, even when those core assumptions aren't really met, is this supply and demand model still useful? Can we still use it to understand or even predict what happens in the real world?
It's a big question. And it turns out economists have been grappling with this for decades. It's actually what spurred the development of experimental economics as a field of study.
And one of the earliest pioneers in this area was Edward Chamberlain. Back in 1948, he conducted what's considered one of the first real attempts to put these economic theories to the test in a lab.
Okay, I've heard of Chamberlain's pit market experiment. What exactly was he trying to accomplish with that?
His goal was pretty straightforward, actually. He had this hunch that the standard supply and demand model, as elegant as it is, didn't really capture how people actually behave when they're trading.
You mean like in a real market where things can get pretty chaotic?
Exactly. He wanted to show that there were systematic differences between what the model predicted and what actually happened when real people were involved. He suspected that maybe, just maybe, the traditional S&D framework, well, it might have some limitations, especially when you factor in the whole human element. We're not robots.
Right, so it wasn't just some theoretical thought experiment. He actually designed an experiment to see how people would act in a simulated market environment.
Precisely. And this work was incredibly important because it kicked off a whole wave of research asking those key questions. When do free markets actually work the way our theories predict? And how can we use experiments to better understand actual economic behavior, the messy stuff? It laid the groundwork for the whole field of experimental economics.
That's fascinating. It really shows how important these empirical investigations are. Now, our sources also give us a more concrete example, a kind of hypothetical lab experiment. Could you walk us through that scenario?
Sure. Picture this. You're in a lab, and there are 10 people, 5 sellers, and 5 buyers. Each seller has a secret value assigned to them. And this is like the absolute minimum price they'd be willing to accept for a certain product. Let's say these values are $2, $2, $5, $5, and $8. And then you have the buyers, and they also have secret values, which represent the maximum they'd be willing to pay. Their values are $1, $3, $6, $10, and $10.
Okay, so I'm imagining these different values, and each person is only aware of their own. So if you were to graph this out, you'd have those stepwise supply and demand curves, right?
Yeah.
Where the quantities only change at those specific price points.
You got it. Now here's the question for you, dear listener. In this little experiment with just a handful of people and where they only know their own valuations, would you expect the market to settle at the exact price and quantity predicted by a typical supply and demand graph? I mean, it makes you think about all the little decisions and interactions that are happening, right?
Definitely makes it more real. And speaking of the different factors at play, our sources break down some of the key elements that can influence what we see in these experiments. What are those main categories?
They basically fall into two buckets: structural elements and institutional elements. Structural elements are things like the number of buyers and sellers, how those valuations are spread out like we just talked about, any limits on how much someone can trade, maybe they can only buy or sell one thing, and even if there are any transaction costs, like even a tiny fee to make the trade.
Okay, so those are like the built-in conditions of the market itself. And then you've got the institutional elements, which are,
Think of them as the rules of the game, the framework within which the trading happens. So can buyers and sellers chat beforehand? Is there a set order for how prices are announced? Are agreements made publicly so everyone knows? Or are they private between just those two people?
so you could have the exact same supply and demand setup, same people, same values, but just change the rules of how they interact, and you might see totally different results.
Interesting. Now, thinking about these structural versus institutional factors, which ones do you think would have a bigger impact on whether the market actually behaves the way supply and demand predicts?
That's a great question, and it gets right to the heart of what Chamberlain was trying to figure out with his pit experiment. Can you remind us about the specific setup he used?
Oh, absolutely. So he took a bunch of students from, because it's an economic theory course, kind of ironic, right? And he gave each of them a private card. These cards assign them a role, either buyer or seller, and a value. So for example, someone might get a card that says B36, meaning they're a buyer and their maximum value is $36. And a seller might get a card that says S20, so their minimum selling price is $20.
Okay, and then what happened? How did they actually do the trading? They were all put together in a room. They called it the pit, which gives you a sense of what it might have been like, right? And they were free to walk around and try to make deals, one-on-one. Once a buyer and seller agreed on a price, they'd go to the front, hand in their cards, and report the price. And sometimes these prices would be written on a blackboard for everyone to see, which is kind of a primitive form of market information, right?
And did it work? Did the results line up with what the standard supply and demand model would have predicted?
Well, not exactly. Chamberlain ran 46 sessions of this experiment, and in 42 of them, the actual number of sales, the total volume, was higher than the model predicted. And maybe even more surprising, in 39 of the sessions, the average price was actually lower than what the model would have predicted.
So the model wasn't exactly spot on then. What was Chamberlain's take on these results?
He concluded his paper with some pretty bold statements. He basically said, look, if you find these results weird, it's because my experiment was designed to be more realistic, to mimic the conditions of a real market. Maybe, he argued, it's actually the perfectly idealized, perfect market. That's the weird one, the one that doesn't really exist. He really pushed for more research to understand these differences between theory and what we actually observe.
He was ahead of his time, for sure. Now, one key thing to note about Chamberlain's pit market is that it was very decentralized. Everyone was making deals one-on-one, and information about what others were doing wasn't always super clear. Another economist, Vernon Smith, who won a Nobel Prize for his work in experimental economics, had a different idea.
Yeah.
He thought that a more centralized market, where everyone had access to the same information and could bargain with multiple people at once, he called it multilateral bargaining, might lead to different outcomes.
And this line of thinking is what led him to develop the double auction, right? Could you break down how that works for us?
A double auction is kind of cool. It's all about transparency. So you have your buyers and sellers, and they each know their own secret value, but that's it. Buyers submit bids, the highest price they'll pay. And these bids typically go up over time as buyers compete. Sellers do the opposite. They submit offers or asks, the lowest price they'll accept, and those tend to go down over time. The neat part is, anyone can accept any outstanding bid or offer at any time. Once someone accepts, that transaction is done, and they're usually out for that round. And here's the key. Everyone can see the highest bid, the lowest ask, and all the prices from previous trades. It's all out in the open.
Ah, so it's much more dynamic than Chamberlain's setup, where things were happening more behind closed doors, so to speak. What were the main things Smith was looking at in his experiments, and what did he find?
Smith kept some of the elements from Chamberlain's design. For example, people still didn't know the overall supply and demand curves or each other's values. And he showed that you don't need hundreds of people to see interesting things happen. But the key difference was this centralized public information flow. People learned about the market by watching the bids, asks, and trades. Plus, Smith often ran multiple trading periods in a row, keeping the supply and demand conditions the same, which gave the market a chance to sort of settle down over time.
And I guess the natural expectation would be that the difference between the highest bid and the lowest ask, that bid-ask spread, would shrink as people got a feel for the market, eventually getting closer to a single agreed-upon price, right? Did that happen? Did the results line up with supply and demand this time?
The results are actually pretty amazing. Smith found that even with relatively simple conditions, people not knowing the overall supply and demand, not being like super sophisticated traders, and with just a small number of people, the markets consistently tended to converge toward the equilibrium price and quantity predicted by the supply and demand model.
Mm.
And even cooler, this convergence happened pretty quickly, and it was very adaptable.
Mm.
When he changed the underlying supply and demand, the market adjusted quickly.
Wow, so it seems like Chamberlain, by trying to poke holes in the S&D model, actually paved the way for Smith to show that under the right conditions, it can be a pretty good predictor of what happens.
Exactly. I guess the key takeaway is that the way the market is structured, whether it's centralized or decentralized, how information flows, can make a huge difference in how closely things match up with theoretical predictions. So in many real-world markets, where we often have fairly transparent prices and some degree of centralized trading, supply and demand might be a more reliable tool than we might initially think. But of course, things get even more interesting when we throw in another wrinkle. What happens when information isn't equal?
Right, we're talking about asymmetric information, right, where one side knows more than the other. And the classic example here is the market for cars, or as it's more dramatically known, the lemons problem.
Oh, yes, the used car dilemma. Everyone's a little wary, right? So imagine you've got a market where people are buying and selling used cars. Some cars are good, some are bad, the lemons. The sellers, of course, know whether their car is a gem or a dud. Let's say sellers would be happy to get $10,000 for a good car, but they'd let a lemon go for as low as $6,000. Buyers, on the other hand, would happily pay $11,000 for a good car, but only $7,000 for a lemon. The catch is, buyers can't tell just by looking whether a car is good or bad.
So the seller has all the cards, so to speak. They know the true condition of the car, but the buyer is in the dark. That creates a tricky situation for the buyer, doesn't it?
It does. A rational buyer will try to figure out the average value they can expect. They might know, for example, that 60% of used cars are good and 40% are lemons. So they do some math. zero point 0.6 times $11,000 plus zero point 0.4 times $7,000. That gives them a maximum willingness to pay of $9,400, reflecting that risk.
Okay, so they're factoring in the chance of getting a lemon, but what about the people selling the good cars? Are they going to be happy with that price?
Not really. If you know you have a good car, you're not going to sell it for less than $10,000, right? So the buyers start to think, if someone is willing to sell for $9,400 or less, that car is probably a lemon.
Uh-huh, they put two and two together.
Exactly. And because of that, buyers become even more hesitant. They lower their offers even further because they figure they're more likely to get stuck with a lemon. And this can create a downward spiral. Sellers with good cars pull out of the market, leaving mostly lemons, which drives prices down even more. In the end, good cars might disappear entirely.
That's the heart of George Ekerloff's famous paper from 1970. He called it the lemons problem, and he won a Nobel Prize for it. This idea that asymmetric information can really mess things up. Now, are there any ways to overcome this problem? Our sources mention a few potential solutions.
Oh yeah, there are things that can help. One is building a reputation. If sellers are known for consistently offering good quality, buyers will be more confident.
Like, if a used car dealership has a solid reputation, you're more likely to trust them.
Right. Another solution is offering signals of quality, things like warranties or independent inspections. It's a way for sellers to say, hey, trust me, this is a good one. And of course, the government can step in with things like lemons laws, which protect consumers if they get stuck with a faulty product.
So it's all about finding ways to bridge that information gap. Now, our sources also give us a real-world example of asymmetric information in action, this one involving computer repair shops.
Hmm.
This sounds intriguing.
This is a really clever study done in Austria. The researchers sent someone undercover to 61 different repair shops with a computer that had a simple, easy-to-fix problem. They just removed a RAM module, which causes a specific error message. Any decent tech should be able to figure that out in like 30 minutes, tops. The cost should be around 60 to 80 euros.
Okay, so what was the twist? What were they actually testing?
They had the undercover person use a standard script to explain the problem, but they changed one key thing: how they talked about payment. In the control group, they just said they needed a bill for the repair. But in the other group, they told the shop that their insurance would cover the cost.
So in that second group, the customer wasn't as worried about the price. What happened? Did the repair shops take advantage of that?
Oh, big time. In the control group, where the person was paying out of pocket, the average price was about 70 euros, right in line with the estimate. But when they said insurance was covering it, the average price jumped to 128 euros.
Wow. Talk about exploiting a knowledge gap.
It's a perfect example of how asymmetric information can distort markets. The repair shops knew the customer wasn't as price sensitive, and they took advantage of it.
A cautionary tale for sure. It shows that these theoretical problems we talk about can have very real consequences. Now let's move on to another area where experimental economics has given us some fascinating insights. Auctions.
Auctions are really interesting. They're a way of allocating goods, especially when people have different values for the item being sold. William Vickrey, who did some groundbreaking work in this area, actually won a Nobel Prize for it. The basic idea is that each bidder has a maximum price they're willing to pay, their private value, and they have to figure out how much to bid to get the best outcome.
Right, because if you bid too low, you might lose out. But if you bid too high, you might overpay. It's a game of strategy. Now, there are several different types of auctions, right?
That's right. Our sources highlight four main types. Let's say we're auctioning off a rare magic card. In a sealed bid first price auction, everyone secretly writes down their bid. The highest bid wins, and they pay what they bid. Then there's the sealed bid second price auction, also called a Vickrey auction. Same idea, secret bids, highest bidder wins, but here's the twist, they pay the second highest bid. Then we have the classic open bid first price ascending auction. This is like your typical auction where the price goes up and up. The last person standing wins and pays the final price. And finally, there's the open bid first price descending auction, sometimes called a Dutch auction. Here, the price starts high and goes down until someone shouts, "I'll take it."
Oh,
They win and pay that price.
those are definitely the main ones we see out there. And there are some key questions that auction theory tries to answer, right? Like, what's the best strategy for bidding and how much money can the seller expect to make?
Exactly. For each type of auction, economists try to figure out the Nash equilibrium that's the optimal strategy, where no one can improve their outcome by changing their bid, assuming everyone else is playing rationally. And they also look at how much revenue each auction type is likely to generate. An interesting question is whether these different auction types actually lead to different outcomes, both in terms of behavior and revenue.
You'd think they would, right? I mean, the rules are so different, but it turns out it's not always that straightforward. So let's break it down a bit. What's considered the best strategy for bidding in a sealed bid first price auction?
Well, if we assume that people's valuations for the item are spread out evenly between, say, 0 and 10, then the optimal strategy is to bid a little bit less than your true value. Like if there are two bidders, you should bid half of what you're willing to pay. The idea is to increase your chances of winning while still making a profit.
Makes sense. Don't want to blow your whole budget on the first bid. Now, what about the sealed bid second price auction, the Vickery one? I've heard that the best strategy there is a bit counterintuitive.
It is, yeah. In a second price auction, the best thing to do, and this holds true regardless of how many other bidders there are or how much you hate risk, is to simply bid your true value.
Wait, really? Why wouldn't you want to try to shade your bid a bit, like in the first price auction?
Well, think about it. You only pay the second highest bid, not your own. So if you bid lower than your true value, you risk losing to someone who bid just a tiny bit higher than you, even though you would have been happy to pay their price. On the other hand, if you bid higher than your true value, you might end up winning, but paying more than what the item is actually worth to you. So bidding your true value is the safest bet.
That's actually pretty elegant and makes the decision a lot easier. Now let's talk about the revenue equivalence theorem. What does that tell us about how much money the seller can expect to make with these different auction types?
The revenue equivalence theorem is a really interesting theoretical result. It does have some pretty strict assumptions, though. It assumes that everyone has the same idea about the distribution of values, that they're all risk neutral, that their values are independent of each other, and that everyone knows their own value for sure. Under those conditions, it says that all four of those auction types we talked about, sealed bid first price, English, Dutch, and sealed bid second price, will, on average, mean the same amount of money for the seller.
Really? So it doesn't matter which type of option you use. That's surprising. But our sources point out that in the real world, things don't always work out so neatly.
Of course, those assumptions don't always hold up. For example, people aren't always risk neutral. Some people are more comfortable with risk than others. This can lead them to, say, overbid in a first price auction because they're really afraid of losing. And there are other factors too, like the the psychological thrill of winning an auction or the fear of missing out. And sometimes people just don't have perfect information about their own values, which throws another wrench into the mix.
So the theorem gives us a theoretical benchmark, but in reality, things can get more complex. Now, we've mostly been talking about private value auctions, where what you're willing to pay depends solely on your own preferences. But there's another category, right? Common value auctions.
Right. In a common value option, the item actually has the same objective value for everyone, but people might have different opinions about what that value is. Imagine bidding on a jar of coins. No one knows exactly how much is in there, but everyone has their own guess.
That makes sense. Everyone's trying to figure out the true value, but they have limited information, and this is where the winner's curse comes in, right?
Wow. Exactly. The winner's curse is this phenomenon where the winner of the auction is often the person who overestimated the value the most. Like, if everyone's guesses are kind of clustered around the true value, the highest guess is statistically more likely to be too high. So the winner ends up paying too much and might even lose money. It's like that saying, you win, but you lose. This happens a lot in things like auctions for book rights, where you don't know for sure how well the book will sell, or even in real estate auctions.
That's a really important lesson, especially in situations where there's a lot of uncertainty. So, as we wrap up this deep dive into market experiments, what are the big takeaways you want our listeners to remember?
Well, I think it's clear that asymmetric information can really distort markets, like we saw with Lemon's problem.
Okay.
And the way auctions are designed can have a huge impact on how people behave and how much money the seller makes. The fact that it's best to bid your true value in a second price auction, that's a pretty powerful insight.
Absolutely. And overall, I think it's been really fascinating to see how these experimental approaches can help us understand and sometimes challenge our basic economic models. So to you, our listener, I have a final question. What's one assumption of those classic economic models that you now view a little differently with maybe a bit more skepticism?
It's something to think about.
Thank you so much for joining us on this deep dive. We've covered a lot of ground, from the basics of supply and demand to the quirks of auctions and the perils of asymmetric information. As you go about your day, try to see if you can spot these concepts in action. Maybe you'll notice information asymmetry in a negotiation, or think about the winner's curse the next time you see an auction. There's always more to learn and explore, so until next time, keep those economic gears turning.